and so developers do not run all the tests, and not at all in fact. So the solution is to select the test by reducing this time from 3 hours to several minutes. So the question we want to analyze and to answer in my thesis is how test selection modifies the developer habits and enhance the software quality. The goal is to save time and improve the quality of the software by selecting the test to relaunch after a change they made in the application. So it can be any kind of test, like performance test, unit test, or performance, or end-to-end test or integration test. So for this, there is two approaches. The static approach based on code graph analysis and the dynamic approach based on the execution of the test. So I will explain you in detail both approaches first. So the static approach, in fact, we create a model of the system, of the source code with Moose, and after we navigate the code graph from the changed method of the source code to the test. So this way we can find which test cover which changed part of the application. So this approach allows to find multiple tracks because it's static, so with conditional like if or switch case, we can find more tests than our approach, but it doesn't require to execute the test because it's static. The second approach is a dynamic one. So here we need to execute the test to have a mapping between the test and the application source code. So after we know which test impact which kind of which method of the application. So if we change the method, we know the test we have to relaunch. But we have to execute the test, and it depends on the data that we put in the test. So if we change the data a bit, we can pass to another condition of the if and to have another coverage of the application. From these two approaches, there is some issues that arise when there is a dependency break in the navigation of the graph. So it can be due to third party by the usage of libraries, of the multi-programs. So when there is a call between a server and a client, we lose the trace between the test and the application tested. There is a dynamic break when you use the reflectivity of the language, and polymorphism when you use the inheritance or interfaces in Java. So yes, at Worldline there is 80% of the projects that are written in Java, so I focused on this language. So for this experiment, we set the dynamic approach like the oracle, the perfect solution, because it's the more precise and safe. But there is some flaws that I will tell you that it's not working on failing test, because if there is a failure, the next of the test is not executed, so there is no coverage for the end of the test, and it requires time to be performed. And for some projects it takes 3 hours. So we wanted to compare the influence of real source code change on this approach. And we do that by simulating some code change on some project of Worldline. So in fact we made two experiments by mining the repository. The first one is to weight each covered method by the number of commits, because in fact, we have only one version of the source code where we can run the test with a dynamic approach. and and after we analyze the Git log to know which method is committed several times. And the second experiment was to group the method in commits. So in this experiment we considered real commits that the developers done in the life of the project. So for this we used 3 projects. So from the worldline environment, so we think that is some representative project. So there are 500,000 lines of code and good code coverage for worldline projects. And yes, we can see that the average method by commit it's kind of low for P1 and P2, but is higher for P2. So for each experiment, we computed the number of selected tests so it's a ratio of the test suite that we select. The precision, it's how many tests are relevant. So it's the number of tests selected by the static approach that are also selected by the dynamic one. And the recall, it's how many relevant tests are selected. As a result, so for the first experiment, by weighting the method with the number of commits, we can see that there is no change in the result. So we select almost 3% of the test suite for P1, 1% for P2, and 2% for for P3, which it doesn't influence the result. The precision dropped a bit, but it's not so much, and the recall too. But if we group the methods covered by the test in commit, we have more selected tests because there is in the commit there is several methods that are changed, so we select more tests. The precision is improving a bit, and the recall is decreasing for P1, but decreasing for P1 and increasing for P3. And we can see that P2 has some divergence in precision and recall. It can be due to the high number of commits. So to conclude, so considering commits instead of individual methods tends to worsen the result, and there is different impact on project. But we have a low ratio of selected tests, so it can be considered as acceptable. So for the future step of the experiment, we want to better understand how tests are launched by the developers and to provide them a tool integrated in their IDE to select the test and ensure a better quality of their software. Thanks.
So we have plenty of time to ask questions. So is there any questions? No? Okay, so first, because we have a little bit of time, you can explain the first feature step. The first feature step, will say what you are doing and how test is done in
Yeah, because in fact we continue the experiment by logging the developer behavior about tests, and we see that in reality they are not launching all, but not launching no test either, and they are selecting tests. So they are running one or few tests of the entire test suite. And
how is the test selection?
so yeah, there are doing test selection, but they are not selecting the true test and enough tests to ensure the quality of the software. So we want to provide them a tool to select more tests that they can do have a better quality in their software.
And so, in fact, I will just finish with that, except if you have another question. Problem is that things are done with Eclipse, and in Eclipse you can only select a test, a class, or a package. It's not possible to select several tests. I don't remember. Yeah, in Faro, at least, with the test runner, you can select several tests together and do your own test selection. But
in Eclipse you cannot do that, and you have to run either one method, a class, or a package. And so test selection is very hard to do.
But yeah.
So a different approach would be, I think, could be to parallelize test execution on a CI server.
Yeah, but we don't want to be that the test runs on CI server. We want feedback to the developer immediately. So if we run the test on the CI, it means that we have to commit the source code and after run it on the CI. So the source code is already shared between all the developers, and we want to avoid that.
I have one more question. Is it possible to adapt what you have done for Faro? Because currently you are, as a developer, selecting the tests that you think are impacted by the change, but you don't know. You are doing also manually your own test selection.
Yeah, that's true. I think for the dynamic approach, we can adapt it to Faro because as Java is a typed language, we know for static approach which is the true path to go from a method to another method. But in Faro, there is no static way to do that. So by the static approach, we cannot do a link between the test and the application, except if you have some type inferencer or something like that. But for the dynamic approach, we know which tests cover which method, so it could be applicable for Faro.
I don't know if you saw Evan's presentation on inferring
Yeah,
types, basically.
So maybe it can be in
because it's likely that the methods that have been run to create the patch are related to the tests that you want to run. And if you get the information from the method cache, then
yeah, it could be an idea.